Hello and welcome to Silux, the podcast where we talk about scientific developments and technological changes in Luxembourg. And in today's episode, we talked to Professor Djamila Aouada, who is head of the Computer Vision, Imaging and Machine Intelligence Research Group at SnT at the University of Luxembourg. The group researches image processing, computer vision, pattern recognition, and generally data analysis. We talked with Professor Aouada about computer vision, image recognition, and its application, as well as bias in data. I hope you enjoy this episode. Our guest today is Professor Djamila Aouada from SnT, so the Center for Security, Reliability and Trust at the University of Luxembourg. Thank you for coming today.
Thank you for having me, Hannah.
I recently came across a very interesting video where they were talking about analog photography and digital photography, and they said, well, yes, okay, now we have digital images, that's possible, but it does not mean that the computers understand the digital. They can really make the photo, but there is a long way to understanding. Could you tell us if my interpretation is correct? This is a bit what computer vision is?
Absolutely, you nailed it. Yeah, it's basically starting from that digital image and trying to interpret, understand as automatically and accurately as possible whatever is in that image or any visual data. It could be a video, it could be 3D data, etc.
I can see you say 3D because that's a kind of fashionable thing to talk about. I'm sure we'll talk about it later. And I just thought everybody knows you in Luxembourg right now, which means that I don't have to say that you're actually heading the computer vision team. And I just went straight into the computer vision, but I'm sure people know it. If not, that's exactly what you're doing. That's why I'm asking about it, right? So yes, so this is that idea, but then we have a lot of applications of that as well, right? So this is the whole teaching them to understand, but why do we do it? Why do they need to understand the image?
Well, think of it, any machine, any computer being able to operate as naturally as possible to replace what we do as humans very naturally. And you can think of it as applications in automatic cars, autonomous driving, in the factory for detecting effects, for entertainment, to understand how someone is moving, animating, etc., etc. And there are plethora of applications touching also medical applications, space, I'm sure we'll touch on that, etc.
Okay, so this basically means that we want something to happen in an unsupervised way. The idea of computer vision is actually giving the power to the so-called machine, or how you want to say it, to analyze the data itself and react upon the data.
Yeah, I wouldn't say unsupervised, I would say autonomously. In an autonomous way with little intervention from humans, from operators. Yes.
Okay. Is it a new field? Because when I was researching computer vision, I have to say that it was pretty new to me. So I started wondering, when did it start?
It's definitely not new. I wouldn't know the exact years, but definitely there is more talking about it. I think the historical path maybe goes more into signal processing, analyzing signals, processing signals, and then progressively those signals became images, so image processing, and then extracting more information from those images, so computer vision. And today, because of having more the need of automating things, so and more investments have been made into computer vision, so it's exploded. But I wouldn't be able to give you the exact year.
Also because there are those buzzwords that appeared and people start talking about it, and then they start talking about computer vision as well, right? Like you said, 3D, and we would have to say AI, of course, and whatever else, or not.
Maybe, 3D, I did my PhD on 3D object recognition, and that was back in 2005. So 3D was always there. I think 2D is faster growing and advancing, but now 3D is catching up. And the link between 2D and 3D is becoming more possible. Hence, I think the buzzword, but it's been there for many years now.
I wanted to understand, before we talk about all these different applications we know about, I wanted to understand, how do you actually help the computer to analyze the image? What is it? Because, okay, I understand algorithms, I understand the image, but what is the link? What do you do? How do you tell the computer to read the dimension or to read the distance and all that?
The image is your data. Image or any video, 3D data, point clouds, you call them, texture point clouds, that's your data, and that's what you input to your algorithm. And you progressively start extracting information more and more abstract, directing it through different steps in your algorithm. That's why we talk about an algorithm. Well, nowadays, the most powerful algorithms are deep learning based. So there is this neural network, which is a concatenation of layers of neurons, and they subtract information progressively until a decision is aggregated and made at the end. It's a sequence of operations, if you want to think about it that way, that are obviously extracted from mathematical operations that are transformed into codes.
And then it will be codes for color, codes for edges, right, and all that.
That's what we call features and different abstractions. So first it's, it could be edges, it could be something that is more abstract that you cannot see, shapes, and then things that we cannot interpret naturally.
So then, if we are analyzing it this way, as we mentioned before, we have a lot of applications for that. And of course, from a normal lay point of view, we hear about, for example, image recognition. Is image recognition part of computer vision or not?
It is. It is, obviously, because it's about, we spoke what is computer vision, is understanding, perceiving images or the world through visual data, and image recognition is part of it, obviously. Now, what is the image about? What are the objects, the shapes on the image? Then you go to subcategories. But that's kind of a starting point. You can do even more and beyond that.
Are there any types of images that are more difficult to analyze and understand than others? Is it human body, or is it, very similar objects? How does it work?
It depends on the application. Now, as a subfield, image recognition is one, image classification. And then you have different applications where images can be, obviously it starts when you start teaching computer vision and image recognition, you start with dog and cats. Those are our toy examples, but it gets way more complicated, recognizing people, where you have scenes that are what we call in the wild, in natural scenes, crowds, repetition, animals, but animals in natural setting. There was someone who was doing classification of penguins. I remember counting of penguins, so detecting them, recognizing them, and counting them, which, might sound easy, but it's very, very complex. But then you have also medical images, recognizing tumors, etc. Space images, recognizing spacecrafts, debris. So the complexity can vary based on the lighting, first of all, the shape, the variations. There are objects that we call them rigid, so they don't deform, and objects that are non-rigid, or humans who are articulated objects. So you have those variations that you have to teach the computer to know and learn. And this is the subtlety of the field.
I love that humans are the articulated objects. That sounds very, very nice, probably for the people who are fighting against robots taking over. This is
we call ourselves articulated objects.
That's a nice one, or rigid, right? Or non-rigid in this case, I guess. The soft ones. Okay, but that's true. You have to analyze it somehow. But it also means, from my understanding, is that you're all able to do this, able to analyze all this, because we have a lot of data right now, right? So you start with this point of having enough data to start the analysis.
to start the analysis and start teaching the computer to capture those variations. So I spoke about shape, position, color as well, with the lighting. And those are the variations that the computer needs to learn to capture what are the objects that we want to identify and recognize.
Okay, before we move on and discuss other subjects and related to computer vision, I know you prepared a pub quiz question for our listeners. So as usual, the drill is that I will ask you to ask the question, and the answer to the question will be at the end of the podcast so that people really listen until the end. So can you please ask the question?
So the question is, who do you think is the most known woman in image processing?
Okay, great. So as usual, don't forget to listen until the very end of the podcast where we'll reveal the answer and discuss a little bit. And now coming back to computer vision. So you also mentioned autonomous driving as one of the things. I mean, I'm trying this podcast to be very much topical, and we've already discussed, 5G, 6G and all that applications for autonomous driving. We discussed that with the lead researcher, Dr. Sebastian Fay, and we talked with Aouada from C2DH about, data analysis and also machine learning and all that. So we've already had a little bit touching upon all these things, but as also computer vision is very interdisciplinary, it's natural that you also kind of address these things in some way or another. So for autonomous driving, this is again the same story. It's about analyzing what the machine is seeing and then taking the decisions, isn't it?
Yes. And it's very much data driven as well. So it's about teaching your car to see all the possible variations with the possible ambiguities. This is where the difficulty comes, be it noise from the environment, noise from the system. So your car or the machine, the computer in the car should understand those variations from the data that you give to it. That's why we base a lot of the learning for autonomous driving based on data. Some simulated data, especially with a lot of simulation engines being so powerful today, as well as real data. So the computer sees all those variations and tries to learn them to make a decision on what is a tree, what is a pedestrian, etc.
And can this data be analyzed in real time and fast enough to react to the situation? Are we already there or not yet?
That's the challenge. We're there in some situations, but do we cover all situations? That's the big question, because with this type of application, you cannot, live with 1% of accuracy or 1% of inaccuracy. So you have to cover 100%. This is the issue there.
And I think also another problem that I often like to discuss with machine learning as such and deep learning and all that is that we're not talking about 100 accuracy, but we can reach it, you're saying, or not, because I think this is a bit controversial in the sense that it's all right or not all right, but it's kind of okay if it's analysis of telling us this is a cat and this is a dog. But when we are having human life at stake, we need to be sure.
We need to be sure. Now, when training is one thing, when testing is another thing. So you have to evaluate your risk. There is always a risk, and there is a risk management of what is acceptable in a given application.
Coming back to the analysis of the image itself and also videos and all that, can we say that the image processing field is kind of very developed and the video processing is still developing, or is it kind of parallel? Where are we? Because my understanding would be that video is the challenge, or it's not. We're already very much into being able to read and understand what we're seeing.
We are quite advanced. I mean, think of video as a sequence of images. So as an image, depending on the application, but we are extremely advanced in all cases. Now with the video, so there is this temporal stream, we are actually doing quite well. Now it depends on the complexity of the scenarios, but I think the results are quite impressive. Now it's about also going into different environments and deploying in those environments, so we have the space, which is a bit more unknown as compared to Earth terrestrial environments. But 2D, be it 2D static, temporal, is quite advanced.
So before we move to space, because you know this is one of my passions in the podcast, so I always want to discuss it if possible. And before we move to that, I just wanted to know also, isn't there any problem of the data we're actually giving, in the sense that, let's say for facial recognition, right? We need to feed the algorithm or whatever with certain data, certain analysis, saying, as far as I understood, I don't know, nose is always a bit light colored in comparison to that part, so this is probably nose, and these are eyes, because if you analyze, that's how it looks. Are we really able to construct and describe a human being in an unbiased way, where we are sure that the algorithm is going to work well and recognize and see what we want it to see?
Very good question. Now, the models of today are mostly deep learning based, meaning data driven. So they rely on the data we give to them. And obviously, if you give only one type of data, the answer is going to be very biased. So it's up to us to feed the machine with a good diversity in the data. But this is the data-driven part. Now, there are also statistical models that are not deep learning based, but those as well need data, maybe where we can model and manipulate a bit more. But there as well, we need to include, be very inclusive in the representation of the population.
And then also, as you said, the space problem, let's say, in the sense that there we don't have enough data, do we? How can we actually do any kind of autonomous application without having the data? It's going to be simulation more and assumptions.
That's the starting point. It's simulation based on models that exist of the sensors, but also of the environment, of the dynamics. But that is not enough. That's just a starting point. An intermediate point is to go to a laboratory environment, and there we see more of the real challenges with the lighting, with the dynamics, and we try to analyze what is the drop in performance when you train on synthetic data, fully simulated data, as opposed to going to lab data. And that analysis, this is closing the gap between these different domains. We call it domain adaptation. And the hope is that we can transfer a similar gap in between lab and real space data. And obviously we need samples from real space data, but we won't have the same amount of data. That's why we need to understand this gap and understand the differences and model the differences if possible.
And we are already able to simulate it well enough to be sure that it's going to, for example, space situational awareness and in general reading space, it's a completely different story than on Earth, right?
Yeah.
With gravity, with other, distortions and noise and all that. But we are already at the stage when we are able to simulate it well when it comes to not deep space, obviously.
Yes. We there are many simulators that exist. We have a couple of them. We have developed our own, and that's what we are using to train our algorithms and models. And we're already testing them on lab data and evaluating how much we're keeping from the performance and identifying the extra challenges.
So is it part of your current research?
Yes,
right
absolutely.
Now? Yes,
absolutely.
Okay. So when you said we have our own, you mean SnT?
SnT and my own research group, yeah.
Okay,
yeah.
So this is part of the research as such. And what are you especially focusing on in that research?
More concretely, we're working on pose estimation. So first, detecting our target in space, recognizing it, and then estimating its position so that we can approach it accurately. So we're working on pose estimation in an autonomous manner.
And how is it going?
Beautifully, I would say. I mean, I have a brilliant team and, extremely diverse, extremely bright. And that mixture is bringing new ideas, and I think we're progressing well.
Of course, and that's not the only thing you're doing, right?
No.
It's just one of the applications. I mean, I know you're a super busy person. I mean, for the listeners, we've been trying to meet for quite some time. So, but yeah, I think you can get that.
We managed.
We managed, exactly. We're finally talking to each other. But yeah, so you said space, but then your personal specialization when it comes to computer vision, what else do you actually do?
Well, as I said, I started with 3D object recognition as my PhD, and then it evolved from there when I joined SnT, working with one industrial partner, IEE, working on depth sensors. So it's still 3D. It's 2.5D to be more precise, something in between. And then we continued with learning representations. So my work as a PhD was about learning a representation or designing a data representation that is efficient and that keeps geometric and topological information using mathematical tools. And the same concept is carried throughout all the applications that we have. And it goes into obviously space as well. When I say, pose estimation, we're talking about 3D pose estimation. So the idea is to embed representations, those deep learning models that still carry representational information from the geometry that we know, be it, invariance or equivariance properties, so that we have efficient models that are compact enough so that we can embed them, but representative and performant.
And I also know there was something about looking at the objects under deformation. Is that something that is more challenging then, because you don't predict that deformation and you need to be able to read it somehow? How does it work?
Yeah, here we're touching on the non-rigid. Going back to non-rigid objects. Yeah, non-rigidity, you also want to model that and that through capturing the deformations. One, I think, very intuitive example could be the face. With our very extensive facial expressions, you can see with the elasticity of the face, this is very non-rigid, and you want to capture that for different purposes and to still recognize a person in this case. So if you're laughing, talking, walking, here not the non-rigidity, but on motion, full global motion, you still want to recognize the same person. Here you have the discussion from image to video. The same applies from a 3D face, so your full face, to, we call it 4D. So the 3D face in motion with all the deformations. So you want to capture that also throughout time.
And you mentioned facial recognition, but like recognition of expression of your face and emotions and all that. What about gestures? Are we already there for understanding human gestures, now to read them?
Yeah, it's very similar. In fact, the models are very similar. We're there to some extent. It's one of the toughest problems.
Also because I guess it's cultural as well. I mean, there's a lot of data and a lot of things. Like, for example, myself, I abuse gestures, which is not classic for a Polish person. We are normally quite calm, at least the people I know. But it's really like we speak also, just very simple nodding. Depending on the language and the culture, you're nodding in a different way.
That's right. Now, when I say we were working on that as a community, we still have the bias. We're definitely working on very small subsets. We don't have these, like for images of dogs and cats, we don't have these billions of images. So it's more on the methods and the models. And the hope is that once you have something that proves good results, then you can extend it, obviously, to a larger population.
Okay, so now it's more about waiting for the data to be there, to collecting the data rather than analyzing it.
Well, of course, there is an analysis and modeling of the gestures, but to reach to a point where it's largely deployed, that, needs more data in addition to the models themselves. It's very important to highlight it's not only about the data, it's a big part of it. It's about smartly using the data, but also modeling the algorithms or the networks that we use.
Of course, I mean, it is about the methods, and depending on the method you use, you also get different results as such, definitely. So it's finding the right one that fits the model and then remodeling the model, if I can say, right?
Yes.
Constantly, because as far as I know, deep learning and neural networks is all about kind of, this recurrent adjustments as such.
Absolutely. And then, I mean, even with the same model, then for new data, you learn new parameters, etc.
Of course, so you can go back. So it's never finished work. Is there a moment when you say, okay, yes, we know, that's it, we don't need to do anything more?
Well, you have to, depending on your application, and we are very applied, so you have to define what your requirements are. And obviously, once you reach those and say, this is the level of accuracy, this is what I need for my application, then you're fine.
Okay. As I have you here and you're an expert in the field, I need to ask something that I guess makes many people uncomfortable, because when we are talking about human factor here and the analysis of the motion and the emotions and the gestures and all that, we need to talk about how it is used later on, right? I mean, we're at a research center, of course, we are not trying to supply the abuse of these, but I guess part of the whole computer vision and image processing is also to be used by, big companies to sell products and all that, right? And we have to face that as well. How advanced are we in this? Are the corporations already using this processing to understand our emotions, or we're not there yet?
Oh, the big corporations are the ones pushing the field. And the field exploded because of the big corporations putting the money and good research teams as well. And a lot of the good results and excellent results are often the result of collaboration between, let's say, public research institutions and private companies, big companies. So it's already out there.
And where are you personally on this? Like, I don't know, Face ID for your phone. Do you use that one or not? Do you close your camera when you are not using the camera? How do you feel about your personal data being used by others like that?
To answer for my phone, no, I don't use Face ID because you can spoof it.
I'm the same.
Whatever is on it is not the most robust thing. That's why we're doing research. But in general, I think as long as there is information and consent, then one should know where the data is going. And should decide whether you want to contribute or not for this your data to be used to improve algorithms. So that's a personal decision. Obviously, in what we do as a public research institution, in our data collections, we always inform the participants, and they have consent forms that they go through, and the data we collect is only used for research purposes. So we make sure that this is the case. We actually share the data with other research institutions, and we have very strict, actually, license agreements where they promise and commit to only use the data for research purposes. Then those data sets contribute in improving algorithms and models and know-how. So other, institutions can go and improve the know-how and models using other data sets, but the data sets that we have, we're very clear in how we collect them and how we share them.
Okay, so that's one side, and there is also another side, which are the deep fakes. Of course, I have to mention that as well. What do you think about it? Are you fascinated that we are able to fake it so well, or...
Yeah, it's fascinating when you see the easily accessible software that creates extremely realistic fakes in real time. That's very impressive. The fact that we as a community reached to this point that quickly. This goes also back to your question, how did we reach there? Because there are big institutions putting the efforts towards that. There is a big business behind it. So it goes fast. So it tells you if research is supported, it can really explode.
That's a very good point as well. Absolutely. And we always need to mention that, unfortunately, right? I mean, we would love the universities to be at the forefront for everything, but well, we know how the world works, and we can leave it there without more commenting. I think it will be enough. But then I wanted to understand that
the ability to create deep fakes as such, is it also related to the ability to process the image, and you would be personally able to do it yourself with your algorithm, or this is a completely different node?
Yeah. This is deep learning as well.
Okay.
It's models that are generative. We call them generative. So they generate this type of synthetic data, but it's learned from patterns and from features extracted from real data. So the machine, basically your computer starts learning what is a plausible face, if we're talking about deepfake faces, and creates things that are, for us humans, realistic. Or manipulates your own face. That's also a deepfake, by giving extra features to your own face or expressions, etc. Yeah, this is all the same, let's say, field, the same machinery.
And I guess also the recent craze of AI art and generating all these DALL-E pictures and all that.
Yes, but I think that's very fun, and if it can, attract interest from a larger public, that's great.
Yeah, of course. I mean, it doesn't have to be always serious application, right?
Yes.
And I think that there's been a lot going on in that, and I'm actually really following sometimes because really crazy things can happen. Unfortunately, I think the free version is a bit limited. I guess it has just less data. For AI generation, you really have to pay, which makes sense as well. We are coming back to funding. I mean, if it's done well, you should be paying for these for sure. And coming back to your research, is there any other field of research that we haven't discussed that you are still looking at? I think there was something about strokes as well, and stroke survivors.
Yes. This is on healthcare. I mean, computer vision is really a technology that can serve many applications, and healthcare is one that I kind of got into that by luck, with, many years ago, collaborating with therapists and healthcare professionals, and I loved it. Because it has this extra human flavor to it, helping people. And obviously it touches me. So we worked with stroke survivors and designed a system to help them to exercise, to do their exercising and rehabilitation at home alone by emulating the feedback that the therapist would give them in a therapy center. So that was computer vision, capturing their emotions and giving them real-time feedback on how to correct their emotion, their posture, and their exercising. And what is interesting is that the system also collects abstract information and metrics from this data and sends it in real time to the therapist and the doctor. So the doctor can actually still monitor what's happening without having to go into the details. So if there is an alarm, for instance, that says, okay, a bit of a drop in performance, or the patient is not doing well, so then you can go into the details of the data, etc. So technologically speaking, it was very fun to design, and it was very interdisciplinary, working with doctors. And impact-wise, humanly speaking, we saw we worked with real patients who were using the system in real time, and we could see the impact. So that was something that I would like to continue doing and replicate, and trying to find the right environment, the right network, because this type of work, you really need to have the medical experts to work with you. It's not just about putting a system and thinking that it could help. You have to work hand in hand with the experts.
Yeah, absolutely. It just reminds me of the discussion I had with Professor Stefan Bordas from university, who is an expert in computational mechanics, and he's very much into interdisciplinarity as well. Yeah. I think it's very rewarding for you, this whole idea of idea exchange and kind of opening up to different fields. And I also asked him whether it is actually possible nowadays to do science that is just, one field, or we all have to be interdisciplinary in some way. I mean, we, the scientists, I put myself in the same shoes. I shouldn't have.
Well, we're all little scientists. I think we all contribute, and even exchanging, I do a lot of outreach with school kids, and those exchanges, those are also the scientists. Everyone is a bit of a scientist. But for the interdisciplinarity, I am a full supporter of that. I think this is from where innovation comes. You cannot be in your corner with the same people, with the same mentality, with the same ideas. You cannot be as creative, as if you were in a group that is diverse, with different scientific backgrounds, but also different, backgrounds coming from different type of training, different countries, etc. That's what really brings innovation.
Of course, and that's what brings sparks to your eyes, I see as well, right?
Yes.
That exchange of ideas, which is so beautiful in research as such, I think. It's just the ability to cooperate with different people. But coming back to what you mentioned, working with the stroke patients, but also other ideas, I was just wondering from the practical point of view. So let's say with the patients, how did it work? Like you put cameras in the room that were observing the patient, or was it a device they were using?
Yeah, we used, in this case, we used a Kinect device.
Okay.
It's a camera that captures your 3D posture.
Okay.
Yeah, and that was one of the condition also in this type of setting, is something that is relatively affordable, that the patient can take home, as opposed to a high-performance system. Well, we actually tried to take the system also with sport professionals. Obviously, they would need a camera that is more of a high performance to have a higher accuracy on their position, etc. So you can adapt concepts to different application, different fields. But yeah, this is to answer the question.
Okay, so there is already some kind of a machine, as you said, that does that.
We used, an accessible camera, a relative accessible camera.
And for space, does using cameras in space just, once again, require a completely new technology, or can we use the cameras we use on Earth?
It's specialized cameras and still an optical system, but the requirements and properties are specifically selected, obviously. And here, the same, we are lucky to have excellent partners who are expert in the space field, so they know the constraints and they are the ones selecting the cameras.
So we're slowly coming to an end. So I think this means we should be now looking at the question once again. I hope you remember the question and the answer as well. So once again, if you can repeat to our listeners what the question was and then tell us the answer.
So the question was, who do you think is the most known woman in image processing?
And the answer?
And the answer is a subjective answer. I'm not sure that this is the most known. You have to run a survey, obviously. But I think for my generation and the older generation, if I say Lena, a lot of people would know. Maybe everyone would know. So Lena is actually an image. We all call it Lena. And whenever we worked on our classes, but also in the past conference papers, journal papers, this is the typical image, toy example that we would be using to run our algorithms for image processing, feature extraction, etc., and compression. And so the story of Lena is she's actually not a scientist. She was a Playboy model. And surprisingly, that image of her face mostly, so from the shoulders up, was used as reference image. A lot of people actually didn't know where it came from. I think now it's more known. And she herself didn't know that she became famous in the computer science and image processing society. And I find it ironic that among all, images, this is what was picked. But it reflects a bit on the community, very male-dominated. I don't think a woman would have picked that picture.
What do you think what a woman would have picked?
Any, I think, random image. I don't know, nature. But certainly not a Playboy model.
Maybe a man. Who knows? Maybe a woman would have picked a man.
I doubt it. I doubt it. But the surprise is that it's been picked, one selected it and used it, but it's been picked continuously until it became the default. This is what you have to test your algorithm on. But it reflects on the community being very male-dominated. Hopefully this disappears. I think there was a meeting to try to let Lena retire. She was found at the end and contacted, so she knows the story. And I googled it. I think I saw a similar picture of her, of her face, shoulders up, with the same pose. I think she's 70 something now, so with the same thing. So I think she was very surprised to discover that this has happened to her without her permission, not to point out.
Yeah, okay, that's also a good point.
She didn't know.
Yeah, well, I guess she was not checking that. She was not specialized in that either. But it's an interesting point which you're saying. So I guess the moment she retires, we will wake up to a different world. And who knows, better or worse? I mean, it's a question of cooperation and opening up as such, I guess, right? But I can see you have very strong opinions.
Well, she did that, Playboy magazine once. And that one time was picked.
As you mentioned it, and I know you are an ambassador of that.
Ambassador is a big word.
Yeah, okay, sorry, not ambassador, but you do talk a lot about it, and also like in the show notes there'll be some information. First of all about Lena, but also some of the videos where you participated in. There was a very interesting FNR series about women in science and all that. So I'm going to share that. People can see a bit more, and we can hope that things will change, whichever way they take us. That we have that ability to cooperate with each other and shape the world. Because as we said, however we look at it, it's important to try to be the least biased possible.
Yeah.
So,
most inclusive, in the data, but also in the teams who work on building the algorithms.
Yeah, absolutely. It's what I always think about my studies. I studied languages, and I would have really been happy with more inclusion on the other side because it was very, very, female oriented.
Yeah.
Yes, that's true. And it's always, we were always happy to talk to some professors, male in that field, because
of course, you need everything and everyone to actually come up with the best.
Yeah, of course. And this is perfect. I can cut it out as a summary of the podcast today. So thank you very much, Djamila, for joining us today. And I hope that we will have a chance to discuss all the advances soon once again.
Thank you, Hannah.
And here we are again. The episode is over. I hope you enjoyed it as usual. Please don't forget to subscribe, to follow us, to check what we're writing on LinkedIn, Twitter, Facebook, and all the other places. As you can see today, my voice was not the best, and I'm very sorry for that. And you can also notice that the interview that I had with Professor Aouada was recorded a bit earlier, and good for that, because I don't think I would have managed otherwise. So once again, thank you very much. This was SciLux, and my name is Hanna Siemaszko.